I greet you all and I hope you are all well. So let's look on writing chemical formulas. So this is chemistry and we're going to look on how to write chemical formulas. So writing chemical formula is simple provided you know the combining elements or radicals. So I'm going to write it down. Writing chemical formula is simple provided you know the so writing chemical formula is simple provided you know the variance of elements or radicals combining. So here when you see we have three terms here: valence, element, and radical. So you need to understand these terms before we proceed. So I'm going to define what a valence is. So a valence is the combining power of element. So this is what a valence is. So a valence is the combining power of element. Again, you know that an element is a type of substance only made up of only one type of an atom and cannot be splitted into two, either by chemical or physical means. So element is a substance So this is what an element is. A substance made up of only one type of an atom. In short, an element is a pure substance. Having defined these two terms, we're going to know what a radical is. So a radical is a group of atoms that cannot exist on their own but needs to combine with other radicals or elements in order for them to exist. So a radical is a group of atoms that can not exist on their own. So a group of atoms that cannot exist on their own are called radicals. So we have defined these two terms. So first of all, we started by defining what a valence is, and we said a valence is the combining power of element. Again, we define what an element is. An element is a substance that's made up of only one type of an atom. I believe we all know the definition for an atom. So an atom is the smallest particle of an element that take place in chemical reaction. So having defined these three terms, we're now going to look on how to write the chemical formulas given the elements and the radicals are combining. So the first step that you need to take is, so step 1, I'm going to write it like this. So this is the first step. So the first step, we're going to write the symbols of the combining element. So the first step, we are going to write the symbol of the combining element. Yeah, so this is the first step. So step one, write symbol of combining elements. This is step one. You write the symbol of the combining element. So having written the symbol of the combining element, we're now going to step two. So this is step two. So this is step one. Step two, you write the valence of each element or radical. So write the valence of each element or radical. So step one, you write the symbol of the combining element or radical. I'm going to give an example. Maybe I've been taught to write the chemical formula for magnesium oxide. Yeah, so this is an example. Maybe I've been taught to write the chemical formula for magnesium oxide. So on your step one, you're going to write the symbol of the combining element or radical. So here we have two elements, and these are magnesium and oxide. So we're going to write this is the symbol for magnesium, and oxygen, this is the symbol. Remember, you write them separately. So having written this, then now you proceed to stage two, which says write the valence of each element or radicals. So this would be the same example I'll give here. So we're going to write this. So if you go at the periodic table, you're going to find that say valence for magnesium is 2 and the valence for oxygen is 2. Remember to write the valence on the top left of element. So after writing like this, then now you proceed to step 3. So step 3. So step 3 says swap the valence. So this gonna swap, this will come this side and this will come this side. So here we swap the valences. So step 3, we swap the valences. So here we're going to have like this. So this will swap, this will come this side and this will come this side. So here we're going to have 2 here, and then here down we're going to have 2 when they swap. The last step is step 4, which says reduce the valence to their lowest ratio. Reduce the valences to their lowest ratio. So after you have swapped, then you reduce the valences to their lowest ratio. I'm going to give an example in this. So on step 3, we swapped the valences and we had something like this. Yeah, we had something like this. The 2 here, 2 after this swapped. So after this, we're going now to reduce these valences to their lowest ratio. So here you look for the number which can go into 2 and this 2 without removing any remainder. So here we're going to find that 2 can go into 2 without removing any remainder, and this 2 and this will cancel. So we're going to have a magnesium oxide like this. Yeah. So on this step 3, which says swap the valences of the combining element or radicals. So when you're dealing with the other radicals, so let's say here on oxygen we're dealing with a radical, so we would have put brackets here to indicate that this is a radical. So let's just do a summary. So we started from here, writing chemical formula. So I started from here writing chemical formula, and here I said writing chemical formula is simple if you know the valence this of the elements or radicals combining. Here I define these terms these three terms, and we said that a valence is the combining power of element. A valence is the combining power of element. And then an element, we said that is a substance that is made up of only one type of an atom. Is a substance that is made up of only one type of an atom. So in short, an element is a pure substance, because we know that a pure substance is made up of only one type of an atom. Again, we defined what a radical is. I said a radical is a group of atoms that cannot exist on their own but need to combine with other elements or radicals to exist. So this is what a radical is. We went further to describe what an atom is. We said that an atom is a substance, is the smallest particle. An atom is the smallest particle of an element that take part in chemical reaction. So an atom, I'm going to write it down here, is a smallest particle of an element that take part in chemical reaction. Chemical reaction here down. So an atom is the smallest particle of an element that take part in chemical reaction. Here the key is chemical reaction. So having defined these terms, we now went on how to write chemical formulas. And our first step when we're writing chemical formulas is writing the symbol of the combining element. Here we said you write the symbol of the combining element or radicals. And I gave an example where we were told to write the chemical formula for magnesium oxide. So at Mg and O, these are the symbols of magnesium, and this is a symbol for oxygen. So having wrote the symbols, we now proceeded to step 2, which says write variance of each element or radicals, as I wrote here. So here we wrote the valence of magnesium and the valence of oxygen. We find that the valence of magnesium is 2 and the valence of oxygen is 2. When you go at the periodic table, you will find that the valence for magnesium is 2 and the valence for oxygen is 2. So having written this, we now proceeded to step 3, which says swap the valences of the combining element or radicals. I gave an example here where we swapped these valences. So this came this side and then this came this side. So take note of when you're dealing with the radicals, after swapping these valences, the radicals are put in brackets. So let's assume that oxygen is a valence. So if oxygen was a valence, would have put the brackets here after swapping. So 2 would have been outside, and then the radical would have been inside the brackets. So and then the last step was reducing the valence to their lowest ratio. So after you have reduced, you now write the chemical formula. So let's look on some of the examples. Okay. So make sure you follow attentively. So our first example. So here, we're going to have example 1. So example 1 will be here. Example 1. So on our example 1, okay, so don't forget we're dealing with writing chemical formulas. This is our title, and let's look on some of the examples. So our first example is writing the chemical formula for calcium oxide. So I'm going to write it down. So I've been taught to write the chemical formula for calcium oxide. So let's begin. So as I said earlier, the first step that you need to take here it's to write the symbol of the combining element or radicals. So here the combined element of calcium and oxygen. So this is the symbol for calcium, Ca, and oxygen of like this. So this is the step 1. Again, step 2, it's to write the valences of the combining element. So we're going to write like this, and then we're going to include the valences. So calcium has a valence of 2 because it's in group 2. And then oxygen has a valence of 2. So having written it like this, we're now going to proceed to step 3, which said you swap the valences. And remember, when we're dealing with the radicals are put in brackets after swapping the radicals. But if you see here, we're not dealing with the radicals, these are just elements. So I'm going to give an example where we deal with radicals. So we're going to swap. So here we're going to have 2 come this side. Again, these 2 will come this side. So this is it, step 3. So in step 3, we're going to have something like this, a 2 here and a 2 here. And then step 4, we said that you reduce the valences to their lowest ratio. So these 2 and these 2 can be reduced to their lowest ratio by dividing with 2. So we have a 2 here and we have a 2. These 2 can go into here, and we're going to have a 1 here. Here we're going to have a 1. So when we're dealing with writing chemical formulas, a 1 is ignored. So we're going to have something like this, calcium oxide, and it will be like this, calcium oxide. So this is calcium oxide. So let's go on the next example. So our example 2, it's here, and on example 2 we have been taught to write the chemical formula for sodium hydroxide. Sodium hydroxide. So sodium hydroxide. So in this example of ours, if you see here, we're dealing with the element and a radical. This is a radical because hydroxides cannot exist on its own but need to combine with other elements or radicals for it to exist. In this case, it has combined with the sodium, and this is an element. Remember where we've come from? We said that a radical is a group of an atom that cannot exist on its own but needs to combine with other radicals or element for it to exist. And we also defined an element to be a substance made up of only one type of an atom and cannot be splitted into 2 either by chemical or physical means. So let's write the chemical formula for sodium hydroxide. So first step, remember the first step. So step 1, I'm going to write it here. I will highlight it. So this is step 1. Also on step 1, you write the symbol for the combining element. So here we have sodium and hydroxide. So here the symbol for sodium, it's Na. So Na is the symbol for sodium, and then the symbol for hydroxide, it's O. OH. This is a symbol for hydroxide. Okay, so on step 1 we have done the necessary, so let's proceed to step 2. So on step 2 we said you write the valences of the combined element on their right top or left top. So here we're going to write like this. We're going to have sodium, okay, like this, and here like this. So remember here we're writing the valences of this combining element or radicals. So sodium has a valence of 1, and oxide also has a valence of 1. So having written like this, we're now going to do step 3, which says you swap the valences, and when you're dealing with a radical, remember the radicals are put inside the brackets, and then the valence will be outside the brackets. So here step 3, so we're going to have this will come this side, this will come this side. So we're going to have something like this. I'm going to highlight step 3. So we're going to have sodium 1 here. Remember oxide is a radical, so we're going to have a 1 here. As I said, you put the radical inside the brackets. So having written like this, then on step 4 you reduce the valences to their lowest ratio. So when you reduce these valences to their lowest ratio, you're going to have here and 1. So 1 and 1, they are reduced to their lowest ratio. And remember, 1, when I'm dealing with writing chemical formula, 1 is ignored. So since here we have 1 and here we have 1, so we're just going to ignore this one. And when the radical is inside the brackets, which is multiplied by 1, the radical is removed outside the brackets. So here we're going to have sodium hydroxide like this. So this is sodium hydroxide. So let's say maybe here there was a 2. So if there was a 2, maybe let's just assume that sodium had a valence of 2. So if sodium has a valence of 2, so we're going to have sodium like this. Let me use a blue marker so that you see clearly. So we're going to have sodium, then 2 here, then the brackets like this. Or you can write it like this, sodium hydroxide. Yeah, it would be like this. So if sodium had the valence of 2, it would have been like this. But in this case, sodium has a valence of 1, so the answer would be sodium hydroxide. So this is the formula for sodium hydroxide. And remember, this is the foundation on more concepts. So if you miss this part, it means that you are going to have difficulties in answering questions on more concepts and organic chemistry. So this is the foundation. Make sure that you follow attentively. Okay, let's do the last example. So this will be our last example. So our last example, we have been told to write the chemical formula for copper 2 oxide. So let's write the chemical formula for copper 2 oxide. Okay, so I'm going to write it here of copper 2 oxide. So here when you see there's a 2 copper 2 oxide, so here we have been already taught that this copper of ours has a valence of 2 because of this 2. So if there was copper oxide, so it would have meant that our copper has a valence of 1. Remember, valence is a combining power of elements or radicals. Also remember that an element is a pure substance, made up of only one type of an atom. We also defined a radical to be a group of atoms that cannot exist on their own but need to combine with other elements for them to exist. So let's write copper 2 oxide. So on our first step, we said that you write the symbol of the combined element. So here we have the combined element, which are copper and oxide. So I'm going to write them here. Copper, this is a symbol for copper, and oxygen, this is the symbol. So step 2, you write the valences of the combining element or radicals. So copper has a valence of 2 according to our question here, so I'm going to put a 2 here. Again, oxygen has a valence of 2 according to the periodic table. Step 3, we swap the valences. So these 2 will come this side, then these 2 will come this side, so we're going to have a 2 and here a 2. Step 4, you reduce the valences to their lowest ratio. So when you reduce these 2 to their lowest ratio, you're going to have a 1 here and a 1 here. Remember, when you're writing chemical formulas, ones are ignored. So we're going to have something like this. So this is copper 2 oxide. I guess for today we're going to end here. Thanks for attending the lesson. We'll proceed in another session. So for those who need online tuition, you can WhatsApp us on this line plus 260 970 quadro 1 30 36. So this is the line for online lessons. Remember to subscribe, and thanks for watching. Have a blessed day.